Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today we are going to talk about logarithms. Now, what exactly is a logarithm? Log base a of m, and that's how this is read. Log base a of m is n if and only if a to the nth power is m. So what this is saying is when they're asking you for log base a of m, it's asking to what power is a is raised to get m. In other words, it's asking for the exponent. So to further illustrate the definition of a logarithm, log base 2 of 32 is 5 because 2 to the 5th power is 32. Log base 3 of 81 is 4 because 3 to the 4th power is 81. Log base 5 of 25 is 2 because 5 squared is 25. Log 1000, and notice it doesn't have a base there. That means the base is really 10. So it's really log base 10 of 1000. Log of 1000 is 3 because 10 to the 3rd is 1000. The log base 4 of 64 is 3 because 4 to the 3rd is 64. Log base 4 of 64 is 3. This is known as the logarithmic form of a log statement. Whereas 4 to the 3rd power is 64, that is the exponential form of the statement. So now then, let's look at some more examples. Let's say you are asked to evaluate log base 2 of 8. So it's asking, what do you raise 2 to get 8? Well, 2 to the 3rd power gives you 8. Therefore, log base 2 of 8 is 3. Log base 3 of 27. 3 is raised to the 3rd power to give you 27. Therefore, log base 3 of 27 is 3. Log base 5 of 625. Well, 5 was raised to the 4th power to give you 625. Therefore, log base 5 of 625 is 4. So again, when it asks you for logs, they're actually asking you for the exponent. Log base 7 of 1. Well, 7 to the 0th power is 1. Therefore, log base 7 of 1 is 0. Log base 2 of 1 over 64. And since it's 1 over something, we know 2 is going to be raised to a negative number to give you 1 over 64. Therefore, 2 will be raised to negative 6 to give you 1 over 64. Therefore, log base 2 of 1 over 64 is negative 6. And log of 100,000, which is the same as log base 10 of 100,000. Well, 10 was raised to the 5th power to give you 100,000. Therefore, log of 100,000 is 5. Now, before we go any further, let me tell you about powers of 10. Log base 10 of any power of 10 is the number of zeros that are in it. There are 5 zeros in 100,000. Therefore, log of 100,000 is 5. So in all these examples, you know what the base was raised to give you the big number. But now, before we go any further, we have what is called natural log, which the notation is ln, meaning natural log. And the natural log of m is log base e of m, where e is 2.71828 and so forth. Okay, this is called the exponential function, e, and e has a set value. So again, the natural log of m is log base e of m. So now we have what is called a change of base property, or calculator property. You don't know for sure what something was raised to get something. So this is where the change of base property come in, or calculator property. Log base a of m equal log of m divided by log of a. And let me give you some examples of that. All right, let's say you are to evaluate. You go round to the nearest thousandth. Log base 7 of 12,567. So this is what you're going to enter into your calculator. Log of 12,567 divided by log of 7. So you're going to enter that into your calculator. And you will get 4.851. Log base 5 of 2,100. So this is what you're going to enter. Log of 2,100 divided by log of 5. So we're going to enter that in the calculator right quick. Log of 2,100 divided by log of 5. And you would get 4.753. Next, log base 11 of 5,176. So this is log of 5,176 divided by log of 11. Enter that into your calculator. And you're going to get 3.566. Log base for 200. So that's log of 200 divided by log of 4. We're going to enter that into the calculator to get 3.822. Log base 6 of 17,497. So this is log of 17,497 divided by log of 6. We're going to put that in the calculator. And you get 5.453. Finally, log base 9 of 1,287,999. So this is what you're going to enter in your calculator. Log of 1,287,999 divided by log of 9. Enter that into the calculator. And you will get 6.403. So this is what you're going to get. Now, the change of base property or the calculator property works on all log situations. So when you're asked to find the log of something, what it's really asking for is the exponent. What power was something raised to get the big number? I hope that you have a wonderful and blessed day.